Hi, everybody. It's really nice to see a lot of you who are familiar faces and familiar names. We'll get started in another moment, but I think I'll make some just really quick points and comments that I want to get out of the way right before the talk. So one new thing that we've done is we've gotten it set up on the Mastodon server Fostodon. So if you'd like to follow us there, we're on an account called rug@hdsi@fostodon.org. So if you're on, anywhere on the Mastodon universe, please follow us. We'd appreciate it. If you happen to end up here without being on our email list, please go to our website. I'll put our website link in the chat and fill out the new member questionnaire. And if you put your email in there, we'll add you to our e-list so you'll get notifications about all upcoming events. And finally, if you're interested in organizing and helping us to organize and you're affiliated with Harvard, definitely let us know. Drop us a line, either email us directly or email our datascience_rug@harvard.edu email address because we'd love to bring on another organizer sometime in the future. So those are my really brief comments and asides. So I'll go ahead and introduce our speaker for today, Emily Zabor. Emily Zabor is a faculty biostatistician at Cleveland Clinic in the Department of Quantitative Health Sciences and the Taussig Cancer Center, where she collaborates with doctors on applied oncology projects and does statistical methods research on early phase clinical trial designs and survival analysis techniques. Emily has authored and contributed to a number of R packages and is a former board member of R-Ladies NYC. Today, she'll be presenting creating publication-ready summary tables with gtsummary. So take it away.
Awesome. Thank you so much for the introduction, and thanks for having me today. I'm excited to be here speaking to you. So I will get started. Before I start talking, I will say, please feel free to interrupt me at any time. I'm happy to take questions throughout the talk, so you don't need to save questions till the end. So I've already been introduced, but just to tell you a little bit about myself, I am a biostatistician by training, master's degree and a Doctor of Public Health degree in biostatistics. And before coming to the Cleveland Clinic, I worked as a research biostatistician at Memorial Sloan Kettering Cancer Center for 9 years. And that's kind of where I was when I got involved in gtsummary. I was colleagues with Dan Soberg, who's the main author and maintainer of the package now. And it was he and I and a couple of our other colleagues who really had the conceptualization to create this package, which started as an internal package, and he really grew and developed it from there. So I'll just start by giving a little background and introduction to the package, and then I'll go through a lot of details of what you can do with it throughout the rest of the talk. So this package, the idea for this package really came about in response to the reproducibility crisis in science. The quality of medical research is often low. There is known to be low quality code in medical research.
Emily, you froze.
And often no coded. Can you hear me again?
Yeah, we can hear you again.
Okay, sorry about that. My computer's telling me my internet connection is unstable, which is kind of shocking because I'm at the Cleveland Clinic, like physically in my office, connected to an Ethernet cable on a desktop computer. So if you can't do better than that, I don't know what else I could do. So probably people are still streaming the World Cup too much. We've been warned not to do that anymore, though. Anyhow, back to, let me know if that happens again and I can pause and back up. So I was just saying that not just low quality code in medical research, but often no code at all. People are producing these numbers and they're going into scientific papers, and there might not even be any saved file that can be accessed to even figure out where these numbers are coming from. So low quality code is more likely to contain errors, And reproducibility is time consuming and it can be cumbersome. And if you really care about it and want to do it well, you need to put some time into it. And so our goal with the gtsummary package was to make it a little bit easier for people to do. So what we really need if we're programming in R is we need to get our code, example on the left here, of some code to make, if we say we have an imaginary data frame called DF and we're trying to get these summaries and tables of percentages of some variables of interest to make a table 1. Well, we all know how to get those numbers in R, but how do we get them into a table that looks like this? This is a table, cut and pasted from a publication. And this is really, we want it to look like this with the nice names down the columns, the nice down the rows and across the columns and well-formatted table. And we don't want to do it with cut and paste because that's a way to introduce a lot of errors. So that is what gtsummary is trying to solve. It can create tabular summaries with sensible defaults, but it is also highly customizable. It is focused on making table 1 type of tables, cross tabulations, and also tables for all types of regression models, including survival data, survey data, custom tables. And it also provides some functionality to report statistics inline in our Markdown reports. There's functionality to stack and merge tables in a variety of ways, and there are some themes that you can apply to get your tables to look certain ways. So I'll go through some of this functionality next. But first, I'll introduce the example data set I'll be using throughout. It's included with the package. It's called the trial data set. And it's just a simulated data set of baseline characteristics for 200 fake patients who receive either drug A or drug B in the context of, say, a clinical trial. And the variables in the data set all have labels using the labeled package. So this is just the first few rows of the data set. We can see the included variables across the top, and this is kind of what the data look like. So I'm actually going to only use a subset of these variables in my presentation today. So I am creating a smaller version of the data set with just 4 variables in it, just for ease of presentation. So we'll be focusing on the treatment variable, which is the chemotherapy treatment group, age of the patient, grade is like a pathologic tumor grade, and response, which is a measure of binary response to the treatment or not. So the first main function in gtsummary is the TableSummary function. And this is the function that will really let you make any sort of table 1 type of table. So the most basic table that we can make is just an overall table of patient characteristics. So let's say we want to just summarize the baseline characteristics of age, grade, and tumor response in our patients. We can do it just with these, 3 little lines of code. And I'm just taking out this treatment variable here because that's more of a, column variable than a row variable. And so I just want to show the patient characteristics. And if we run these 3 little lines of code, this is what we get automatically in from TableSummary. Just the overall characteristics. By default, you'll get the median and IQR for continuous variables, and the N and percentage for categorical variables. By default, it will also print any unknowns as a separate row in the table and give you the overall sample size with a little footnote telling you what those presented numbers are. There are 4 types of summaries possible: continuous, continuous 2, which I'll show an example of to explain, categorical, and dichotomous. And the function will just look at your data and try and guess what type of variable each one is. So you can see here, I didn't actually have to say what type of summary I wanted for each variable. It, saw this was a numeric variable and it treated it as continuous for age. It saw that grade was, had 3 levels that were character levels, and it treated it as a categorical. And tumor response, it will see any variable coded as 0, 1, true, false, or yes, no, and by default, we'll treat them as dichotomous and just provide a single row summary for those. And if your data are labeled, it will print those labels automatically. So you can see here, I'm getting the actual labels for the variables and not their underlying variable names by default. So that's the most basic table. And there are a lot of options for customization. So the first thing we might want to do is have a column variable. So we do that by specifying the by argument in TableSummary. And so now I'm going to make my table by treatment group. So we see I have the same variables down the rows, and now I have two columns, one for drug A treatment group and one for drug B treatment group. The next customization we might want is to change the summary type, the type of a variable. So by default, this age variable was treated as continuous, but I want it to be continuous too, which is an option to have one or more lines of summary for a continuous variable. And I'll show you a little bit more of what I mean by that in a slide or two. But by switching to continuous too, now, instead of having that summary just on this row with age, I get this separate row down here with the median and IQR and my unknown values. We can also customize the statistic by using the statistic argument. And so here I want to customize what's being produced for age, and instead of the median and IQR, I want the mean and the standard deviation. And I also want to show the min and the max, so the range of this continuous variable. And this is where the continuous to type really comes in. So by using continuous to, I can now have two or more summaries for my continuous variable on separate rows. And so you can see here now for age, I have one row for the mean and standard deviation, and a second row is produced now for the range of that variable. And this is sometimes of interest with a continuous variable. And then for my response, I'm saying that instead of the default of n%, I actually want to show, the little n over the total sample size for that group and the percentage. So it's just adding the denominator into this tumor response. And you can see that I can specify multiple variables in a list to change the statistic, and it would be the same for type and these other arguments as well. You can use a list for that. I can also change the labels. So like I said, if there are labels in your data set, it will automatically use those labels, but sometimes either a variable is unlabeled or the label that's in there isn't really detailed enough. So in this case, I'm going to use the label argument to change grade from just saying grade to say pathologic grade. So the only thing you can't change easily is the levels of a categorical variable, which you really will have to change in your data itself if these levels aren't informative enough. An additional customization is the digits. So here I'm saying in the digits argument, I want age to be rounded to 1 digit. So there are sensible defaults for the digits, and you can see in the previous table, it was rounding these to have no decimal places because age, who thinks of their age? For continuous, for age, yes, but for any continuous variable that's like over 2 digits, it will round to have no decimal places. And I think once it's down to a 1 digit, then it adds 1. And if it's 0, then it adds 2 after the decimal place. But you can change it however you want, and each variable can be different. So here I've just said I want age to be 1 decimal point. So now I have that in both the range and the mean and standard deviation. And you can change it for categorical variables too, if you want more digits on your percentages. So the basic way that we customize is we provide an argument, one of the arguments to TableSummary. Then after the equal sign, we select variables, and we can select these using all of these like kind of tidy select options. So if you want to apply a change to all of the continuous variables, you can do it in this way. You can specify a single variable with the name of the variable. You can use starts with, ends with, all of these nice tidy select functions are available to make changes to your variables. And then you use a tilde and you provide the instructions that you want to do. And we use the glue package a lot in this. And so that's the best way to make the changes to the statistics that you want to be presented, is by using the keywords that come with the glue package. And these are listed in the help files of TableSummary, so you can get some ideas of how to do this. But using the glue package is just with the curly brackets around the keywords, and then anything that's not a keyword is inside the quotes and it will show up. And then, as I mentioned earlier, you use lists to pass 2 or more choices. So anything inside a list, you can make multiple changes to multiple variables. Any questions about this before I move on?
I have a real quick question. In the output for age that you formatted with continuous 2, you had like mean or median and interquartile range on one line, and then the range on the next line. And I saw where you gave the functions, or yeah, I see where you're giving like the glue syntax for that, but how does gtsummary know to put like mean parentheses SD as the row name for that? And same with range. Like if I introduced another function, how would it know what to call that line?
Yeah, so it's looking at this vector that I'm supplying to age, and each individual quoted string in the vector will be 1 row in the table. And so it knows that this string is going to be 1 row, and this is the mean, and the parentheses SD, and then whatever comes after the comma then will be the next row. And if you put another comma here and added something else, you would get a 3rd row. Yeah, so it just looks at the pieces of that vector. And if I took this part out and just had the mean and SD part, it would just be 1 row with the mean and SD. Does that make sense?
Yeah, I'm wondering like where the word range appears in the table. Like where is that coming from?
Oh, that is a good question. I think it's just guessing that from the min and max, which it knows to be the range. You would be able to change that label though, I think, but I actually don't know how to do that. That's a really good question. I'm actually not 100% sure about that.
Okay, I'll dive into the docs.
I'll have to look in the help file. Yeah.
Okay, thank you.
That's a really good question. Okay, so that was the basics of TableSummary and the arguments, quite a few of the arguments that you can use to customize the output of TableSummary. And there are also a lot of add-on functions for it that can update the table with additional information. And these come in kind of 3 main classes. The first is functions that start with add underscore, and these will add an additional column of statistics of information. For example, p-values, overall statistics, and other things. The second class starts with modify underscore, and these functions can modify the table headers, the spanning headers, and footnotes of the tables to customize those. And then the third class start with either bold underscore or italicize underscore, and these can really help style the different labels and variable levels in your tables. So I'll show some examples of these. So probably one of the most common things you'll want to do with a table 1 is to add a column of p-values. So you saw that just TableSummary in and of itself is just providing the summary statistics, and you have to use this add-on function add underscore p to add the p-values. So if we just do that, that's this part. This is our basic TableSummary going back to all the defaults by the treatment variable. And then if we just pipe that into add p, we get the column of p-values, which is here. And it adds a little footnote saying what tests were done. By default, it will do the Wilcoxon, a non-parametric Wilcoxon rank sum test for continuous variables. And then it will actually calculate the expected cell counts for categorical variables and choose between the chi-square test and the Fisher's exact test for categorical variables. But you can customize all of these statistical tests as well. Those are just the defaults. And then the other one I've added here is called add q, and this can add a column of adjusted p-values. This would not make sense in a table like the one I'm showing this example, but say if you had a table of a bunch of SNPs from a genetic study and you were looking at them by group or something, it might make sense to adjust those for multiple comparisons. And this just passes a call to the p.adjust function in base R, and by default it does the false discovery rate, but you could specify any of the adjustment procedures that are available in p.adjust. We can also add a column of overall statistics. So you saw by default that we only get a column for our 2 treatment groups, but sometimes we might want to see a column of the overall population summary. And so we can get that just by using add_overall. We can also add the sample size. So in this case, I've done 2 things in this table. First, you'll see that inside the table summary, I've added the option missing equals no. So it's taken out the rows of unknowns from the rows, and instead I'm adding a column of the sample size for each variable. So you might want both, or you might just want one of these things, but it's just another way to show, we have 200 people in this study, but for age, we only know 189 of the values. So that's another way that you could include that information in your table. We can also add different labels for our statistics. So once we put in the AddStat label, we'll get rid of our footnote down here. So if you use AddStat label without anything in the arguments, it will guess what your summaries are. So here you can see for age, I didn't specify anything, but it's added that it's the median and the IQR just because it knows what these default statistics are that are in the table. But I'm telling it specifically that I want the label for all of the categorical variables to be NO dot and then parentheses percentage. And so you can see here that after grade, now it says comma number percent. So we know that's what's being produced in this table. And once you've added these stat labels, now you don't have the footnote saying what these statistics are anymore. We can also add differences if we want to get a table of differences between variables. Sometimes that's something of interest. So in this case, I'm going to look at a continuous variable, which is called marker. It's just some generic biomarker level on the patients in this, simulated trial data. And then our response to chemotherapy is my column variable. So you can see that first I am just summarizing this using my table summary by the treatment group, and it takes any other variables that are in this data set and put them on the rows. So we have tumor response and we have marker level. And so this is what we've seen before, where our columns for our 2 treatment groups are being summarized. Only in this case, I've asked specifically for the mean and standard deviation for my marker variable and just for the percentage for my response variable. And now I'm going to use the function add difference. And what that does automatically is it computes the difference between the means and then also the difference between the percentages and with a 95% confidence interval and a p-value for the test of the difference between 2 groups. And the last function, I won't go into a lot of details, but there's a function called add_stat, and you can basically supply any user-defined function to this to be able to add some other statistics. So if you have some sort of complicated study design, or you need to use, a t-test with unequal variance, or, some sort of customized thing, you can write a little function yourself to do that test. And then you can use the AddStat function to pass your function argument to this. And the help file gives some examples of how to do that. All right, so that's kind of all the add-ons for TableSummary. The next section I'll talk about is bolding and italicizing. So there are a lot of options here, but some of the more common ones are to bold labels and italicize levels. So here I have my table summary. Again, I have my 3 variables on the rows and my columns for my 2 treatment groups. And now I'm asking for the labels to be bolded. So that's these main rows here, age, grade, and tumor response. And by adding then italicized levels, the levels of each of my variables are being italicized. And finally, I'm asking to bold all of my p-values in this case that are below 0.8. And I'm only using that weird cutoff because in this case, there weren't any significant p-values. So it's just an example, but you know, you might want to bold all your p-values that are less than 0.05 or something more meaningful. And so then you would just give the T specifies the cutoff below which you want to bold your values. So here we can see the very important result that age has a p-value of 0.7, whereas grade has a p-value of 0.9. So it jumps right out at you. And then we can also update the features of the table itself using the various modify functions. So again, here I have my trial data. I'm just selecting 3 variables now, age and tumor response and treatment. And I'm going to make my table according to my treatment variable for the columns. And now I want to update the header rows. So if you recall before, this said drug A and drug B with the sample size next to it. But I want to modify that header, and I'm doing that here. And so I say update equals, and I'll show you how to figure out how to get this information in just a second, but this is the way I update it. So I'm going to update both columns. And for the column stat_1, I just want it to say A, stat_2, I want it to say B. And so we can see now I've modified this header. There's no sample size, and it just says A and B. And then I can also modify the spanning header. I think before there wasn't one at all by default. So now instead of saying drug A and drug B, I'm going to put drug over them. And I can see I have drug A and drug B. And I do that with modify spanning header. And then I can also modify the footnote. I think, I don't remember what it says by default, but I'm saying for all of my statistic columns, I want to say that it's the median IQR for continuous and N percentage for categorical, which is basically what it said before was this median IQR, comma, N percentage, but now I've made it a little more detailed potentially. Okay, so to use these modify features, we need to know what the underlying variable names are in our table. And to do that, we create a table and assign it to a name. So here I'm going to create just a little table from my data set just by the treatment variable. I'm going to call it TBL. And then I can use the function show_header_names on my table. And it will print off in your console what the different column names are so that you can use them to make those modifications. And this is exactly what you'll see in our, they'll say as a usage guide, the code below recreates the current column header. So we can see that the column that is labeled characteristic is called label. The column that was originally labeled drug A N equals 98 is called stat_1. And the column that was originally labeled drug B N equals 102 was called stat_2. And so that's how I knew over here to update stat_1 and stat_2 to get those different column headers. And it can also give you an idea of how to, get the syntax for Rmarkdown for bolding. The 2 stars. I'm sure you're familiar with Rmarkdown, but the 2 stars is for bolding, and so you can kind of see how to use that syntax too. It's a useful thing to be able to see these header names. And just one other note is that there's a custom select function in the gtsummary package called all_stat_calls, and it'll select all of the statistics columns. So in this case, we just have stat_1 and stat_2, but if you had a bunch more columns, it would be all of those. So you can see on the previous slide, I used that to make a change to the footnote for all of the statistics columns. Okay, and there are a lot more add-on functions, actually. I just covered kind of some of the highlights. So there's a lot of customization available, and there are details on the package website of some of the other options. But I think that covers kind of some of the main things we might want to do when we're making a table 1 to go into a publication. So just a couple more things in this section. There is a function TBL_Cross, which is a wrapper for TableSummary for two-way contingency tables. So basically, you just specify a row variable and a column variable. In this case, I'm going to say my row is treatment group and my column is grade. And then you can say what you want your percentage and margins to be, if you have any margins at all. And so in this case, I'm saying I want row percentages. So I want to see the percentage of grade within each row of treatment. And then the marginal row is on the bottom. So I wanted a marginal row of row. And so what I get here is just a 2x3 contingency table with my percentage numbers and percentages in the cells and the total. And you can see here when I use now the add_p function on this, it by default will make a source note. So that is just a footnote here saying it did a Pearson's chi-square test and the result was 0.9. There's also an option to make a table of all continuous summaries using TBL_continuous. So in this case, if we pass our trial data into TBL Continuous and we say the variable of interest is age, so that's the continuous variable we want to summarize, and we want to do it by treatment, that will be our column variable. And then I'm saying in this case, I also want to include grade. This will stratify on the rows our continuous variable according to grade. And so what I get from this is I have on the rows the grade, on the columns I have the treatment group, and now in the body of the table I have the values for age in the default of the median and IQR. So I can see that for patients who were grade 1 and got drug A, they had a median age of 46 with an IQR of 36 to 60. So some of these functions I've personally never used, but they're all in here because someone requested them, or these are things that other people do. So I think they can be useful depending on what situations you're working in, because there are so many different contexts of clinical studies that we're working in. I only use certain functionality within, my world of cancer, but someone working in another area probably uses different things all the time. So just a couple more things in this section, I think. This is some newish functionality. And again, I've never used this myself. I don't work in surveys at all, but there is support for survey data now with TableSummary. So if you say you have to specify a survey design before you use the table function, and I don't have any expertise in this at all, but I think what this is saying is we're not going to cluster our data at all. So we don't have any clustering. Here's our data, which is this, built-in R data frame Titanic. And we're going to supply weights to our data, sampling weights based on a column in the data that's called frequency. And so then if you pass this into TBL_SurveySummary, and I want my table to be by whether they survived or not, and the variables I'm going to include are class and sex, I can get this table. So now I have my 2 columns of survived, no or yes. The class and the sex are on the rows, and I have my numbers and percentages, but they've accounted for those survey weights of frequency now. And you can use all of the other add-on functions along with this to add p-values and modify the headers and whatnot. And you can see here that the default p-value now is the chi-squared test with Rao and Scott's second order correction. And I don't know what that test is, but presumably it is an appropriate test for weighted categorical variables. And of course, as with everything else, you can change that test statistic by customizing it yourself. There's support for survival outcomes, which is great for me. I do a lot of survival analysis. So if you do a fit of using the survfit function from the survival package, then you can supply that as the first argument to this function TBL_survfit. And there's a few different things you can do with it. If you use the times argument, you'll get the percentage, you'll get like in this case, these are months. So I'm saying 12 and 24. So I'm getting the 12-month and 24-month survival estimates. If you use the probs, I think the argument is called probs, you'll get, like if you said probs equals 0.5, you would get median survival, or you could specify some other quantile of probability. So if you wanted the 25th percentile of survival for some reason, you could get that as well. So the times argument gives you the percentage, and the probs argument would give you that median value if you said 0.5, sorry. So that's what you get from this. And then I'm modifying the label header to say, I want it to take the time, which is from this vector here, and then add after it month so that I know what the unit of the time is. And then I'm adding a p-value, which is just the log rank test. So we can see I get this table where on the rows, I have the chemotherapy treatment, and now I can see my estimates of overall survival at 12 months and 24 months according to those treatments. All right, so the next section will be on regression tables, but before I move on, I see there's a lot of stuff going on in the chat that I'm not looking at. But before I move on, are there any questions I should look at there, or does anyone want to unmute and ask a question about summary tables?
I just think it's fantastic that you have support for survey weighting, especially. And I mean, all of the different kinds of designs that you support are amazing to see.
Yeah, and it's, you know, functionality. Dan is actually really responsive to what users are asking for. So he is the main developer of this package still, and the survey methodology was being requested a lot. A lot of people wanted that. And so even though that's not something that he or I ever really do regularly, that he added that in. So in consultation with other people who work more in those methods to make sure it was accurate, of course. Yeah, I think it's great. So if you ever see something, you know, think of something that you do over and over that you can't do with this package, it's definitely worth putting in, you know, an issue in the GitHub on the GitHub page and asking for, you know, new functionality. Okay, I will go on to regression tables. This is the second major piece of functionality other than summary tables is regression tables. So the you know, traditional model summary that we'll see in R, say we want to fit a logistic regression model. And in this case, I want to look at tumor response according to both age and stage from my built-in trial data. And I'm saying that I'm using the function GLM and I have a logit link. So I'm going to get a logistic regression model. And when I summarize that in R, everyone's seen this before. This is what I get now. How do I put that into my paper to get a nice table? Well, it's very hard to understand, and it's certainly hard to get what you want out of this. So the function TBL underscore regression will do this for you without any other arguments. If I say TBL underscore regression, I get this table on the right, and it displays p-values automatically in this case, unlike the summary tables, and it shows reference levels for categorical variables. So you see here, we get dashes for the reference level for stage. You can also customize how you want your reference levels to display. And it does recognize in this case that it's a logistic regression model, and by default, it prints log OR over the column of regression parameters. And you can see you get confidence intervals as well. We can customize this output quite a bit too. A main customization you might want in the context of a logistic regression model is to exponentiate those regression parameters to get the actual odds ratios. So there's an argument exponentiate that you can say equals true. And now instead of log OR, we have our odds ratio, and it automatically also exponentiates the confidence interval. And now I'm going to also use the function add global p to add global p-values. If I go back to this table, you can see by default, it puts a p-value, it puts the p-values right from that summary table for each level of the categorical variable. But most of the time, what we really want to know is there an association between T stage overall and our outcome of tumor response? So if we do add global p, we'll get those global p-values instead. And then you can also add all sorts of other statistics. So in using this add glance table, there are quite a few options. Basically anything that comes out of a regression table, as long as you get the right keyword, you can add it. So here I'm adding the number of observations, the log likelihood, the AIC, the BIC, just to show some examples of what you can do in these tables. This is a long list of the currently supported regression models. And basically we can support any model that can be tidied using the tidy package, or that someone's contributed a custom tidier. But also you can write your own custom tidier and pass it to table regression to basically be able to do any regression model that you want. So one of the things that I do sometimes is I'll fit a parametric survival model, or I'll do an interval censored survival model. There's not support for that here, but I've written a custom tidier to basically what you have to, all you have to do is you have to get the output of the regression model into the same form that the tidy package would, the tidy package would get it into, and then you can pass it to this and get that output. But there's quite a few models supported now. You can also do univariable tables with table UV regression. You could see that using the previous function, you would be able to do a univariable table for one variable. So because it just takes a model fit. So if you just did a univariable model and passed it to table TBL underscore regression, you would just get a univariable table. But sometimes what I want is a bunch of variables on my rows, and I want a univariable regression model for each of them, and I don't want to have to fit each one individually. So what we can do is use TBL underscore UV regression, and what it'll do is it'll basically fit a regression model for every variable in the data set that you pass to it. So you do have to select the variables that you actually want to be on the rows, similar to TableSummary. And you have to say the method. So in this case, I want a GLM because I'm going to do a logistic regression model. You have to say what the outcome variable is. In this case, it's my tumor response called response. And then you have to specify any other arguments to the function, just in the same terminology that you would use in the GLM function itself through the method.args function. So here I'm saying that my family is binomial to fit my logistic regression model, and I want to exponentiate all of my regression parameters. And so once you've specified these three main things, the method, the method args, and the response variable or the y variable, we can get a table of univariable statistics. So now univariable regression models, every other variable in my data set goes onto the row, and a logistic regression model has been fit, and the results are printed here. So you can also use the same helper functions that I've shown before to bold things and add p-values and all of that here. Okay, so I just have a couple of more little things before I wrap up and take any questions. The next is inline text. So tables are important and probably the main thing that we need for publications, but often we also need to report results inline in a report. So if you're writing an Rmarkdown report, you have something in a table, but you want to describe it more. So any statistic that is in a gtsummary table can be extracted and reported inline using the built-in inline underscore text function. So you can modify it, but it does have a pretty sensible default pattern, which is the estimate. So if you have a model, it'll be the model estimate. In parentheses, it'll put the confidence level, and then the confidence interval, and then after a semicolon, the p-value for regression summaries. So I'll show you what this looks like. So let's say I have this table that is named M1 underscore table underscore 3. That's what the object name of this table that gets produced here is called. And I want to get the odds ratio for age and put it into the text. So I want to say something about this 1.02 in my text. So I can write in my Rmarkdown document that the odds ratio for age is, and then I actually put this, these are backticks. they didn't print quite right, but I would actually put this in line in my Rmarkdown document, and what you would see is this. So all I have to say is inline text, say what the table is and what variable I'm interested in. And if I like that default pattern, it'll give me the odds ratio, the 95% confidence interval, and the p-value right into my report. So this is kind of another nice reproducibility step where I don't have to, type out these numbers from my table into my text itself. And there's a lot of information in the help file about how to find the pieces that you want or how to change those patterns. We can also merge and stack tables, which is something that we often might want to do. So I'll just show a few examples of this. Say we want side-by-side tables of univariable and multivariable results. We can create the univariable table, as I've shown before, using TBL UV regression, and we get this table here. Now I'm just looking at age and grade on my rows, and this is a survival model. So we have a hazard ratio and confidence interval and my p-values. And over here on the right, I have a multivariable table. In this case, you actually fit the model in whatever function you're using. So Cox pH, and just pass it to table regression. I want to exponentiate to get my hazard ratios, and again, adding global p-values. So now I have these two tables, and I want to combine them. I can do that with TBL_merge, and I just put the tables I want to combine in a list, and it'll put them side by side. And if I want, I think by default, it'll just say like table 1 and table 2 here, because it doesn't know what you want to call them. So this tab_spanner argument lets you customize what you want to call those two tables. So I'm calling mine univariable and multivariable. Sometimes we might want to vertically stack tables too. So an example of that might be an unadjusted model, where I have a survival model here that only has the treatment variable in it. And so I do my table regression, and I'm saying I have my treatment variable, drug B versus drug A. I'm exponentiating that. And now I have an adjusted model. So I have my Cox regression model again for my survival data. And now, in addition to treatment, I'm adjusting for grade and stage and marker. And so now I'm passing that to table regression. In this case, I need this argument show single row, which is saying I only want to show the row for treatment. I don't want to see these adjustment variables. And I'm just labeling this to look the same as the other table. And now I can stack them. So using TBL_stack, again, I just use a list. Those two tables were named T3 and T4. So I just list the names of the tables. And now I use the group_header to label the group. And so up here I have unadjusted, and down here I have adjusted. And of course you would want to put a footnote or something to say what this was adjusted for. In this case, I haven't done that step, but or you could even show all the rows if you really wanted to. But so that's just an example of how to vertically combine tables. I think maybe the last thing I have in this little section is, I know I'm getting down for time. I want to leave time if there are questions, is stratified tables. So this is a pretty new functionality, TBL_strata. So you actually it's also a wrapper for TableSummary. So you just say what your strata variable is. Here I'm going to say grade. And then you actually put your regular call to TableSummary with any modifications right inside table strata. And so now it's going to make a summary table for all of my variables according to treatment. And I'm going to modify the header in this certain way. And what I get is my variables on the rows. And now I have my table according to treatment, but it's stratified by grade. Okay. I'll just go through this pretty quickly because these are some nice little options for themes of the tables. So a theme is basically a set of customization preferences that can be easily set and reused. So there are some default settings for existing functions, and you can also include some more fine-grained customizations. And you can either use one of the available themes or you can create your own. So if there's something that you find yourself wanting to do over and over, or a certain preference you have, you can create your own theme. And so I'm using this here because I wanted to make sure there was no cluttering up of my themes. So to go back to the default theme, you can use reset gtsummary theme. And so now I'm going to make a table. I'm using my trial data set, and I'm going to select age, grade, and treatment. And I'm going to use TableSummary to get a table by treatment in the columns and the other two on the rows. And I'm adding my statistics label and my p-value. And I'm going to call this default theme. So this is what it looks like by default, which is what we've been seeing. So now there are some built-in themes for certain journals, and the ones that we have available are for JAMA, Lancet, New England Journal of Medicine. And I actually do not know what this journal is. Someone must have contributed this. QGCon, if anyone knows, but these are journals that have like pretty specific stylistic requirements for tables when they publish them. And you can just use theme _ gtsummary _ journal and then specify the journal. And you can get, for example, the JAMA theme, which I guess has median and IQR with dashes and no percentage signs within the percentage parts. And if you have another journal you'd like, you can contribute it. There are also options to have your tables printed in different languages. And here's some of the available languages. And you just use the theme gtsummary language option. And in this case, I'm making an example table in Hindi. One other built-in theme is the compact theme _ gtsummary. Compact just reduces the padding and makes the font size a little bit smaller. But yeah, and then you can use set gtsummary theme to create your own custom theme. And if you go to the help page for that or look at the vignette for themes, there are some examples of creating custom themes and all of the options for that. Okay, now I'm really almost done. So just the last thing I'll show here is the print engines. This is just for, using gtsummary within Rmarkdown documents, depending on what kind of output you want, how your table will actually be printed. So by default, it uses the GT package to print tables if you're using HTML output. But by default, if you're using Word output for your Rmarkdown document, it uses Flex Table, and there are some others, but you can see here just what's well supported in the different output types and what's not. And you can change this in your settings for gtsummary, how you want your tables to print. Okay, so just leave you with a few resources, which is the package website, which has a ton of resources. It has great vignettes, and for a lot of the stuff I brushed over, you can find more details here. Just the basics of installing the production version from CRAN and the development version from GitHub. And you can see that the package has gotten kind of popular in the last year or so. And just to recognize all of the different authors, and this is not all of the contributors, this is just the main contributors. Lots of people have contributed little things to this package over the years. And thank you. And I'll leave you with my contact information, and please do feel free to connect with me in any way or send me an email about anything. I'm always happy to answer questions.
So there was one question in the chat just recently ago, which was, can you share your slides?
Oh yeah, happy to. They're actually available online. They're already available online. So let me just put I'm gonna stop sharing my screen, and I'm just gonna get the address for that and drop it in the chat. They're just on my website.
Thank you.
Yeah. Put this in here. I'd be happy to send them too, but they're online, so everyone can get them that way.
I think the vibe is that everyone is super impressed with the package. I think I was blown away pretty early on when you were showing that it can automatically produce like difference columns. That already, I was like, wow,
Yeah.
This is a package after my heart. Earlier, before we got on, you had said, you think I'll like it, and I totally do. So
Yeah,
Thank
I
you
mean,
so
I think
much.
that's great. The cool thing about this package, I think, is that it was conceived of and written by people working as biostatisticians, you know, in clinical research. And so we come up against these problems over and over and are always having to make these same types of tables over and over. And so I think the nice thing about this package compared to some of the there are other great table packages out there, but I think some of them are not written with the specific kind of goal in mind of summarizing, you know, clinical or epidemiologic data. So I hope that there's good stuff in there for everyone.
Yeah, your examples, I mean, so Nicole and I work in epidemiology, and, you know, just at least from my perspective, the examples you were giving of like stacking unadjusted and adjusted models, or putting side by side, you know, univariate models and multivariate models, that's something I won't say like I want to do like all the time, because it's like actually months in between when I do it, or years,
Yeah.
but it's something that I regularly want to do. And it's just great to see that kind of functionality implemented.
Definitely. And it's so nice to be able to do those things in a reproducible way. So you have that code saved, you can just find where all those numbers came from, and you don't have to, you know, manipulate the tables after the fact. So
Yeah. Well, I'll pause. Are there any other questions? Oh, Todd.
I don't really have a question, Emily. I just wanted to say thank you. This is really awesome. The table regression, that's life-changing. I don't understand why that's not a requirement in like the basic stats classes with R. Yeah, there's no reason to read a regular summary of a regression anymore. I wish I knew this 2 years ago. Thank you.
yeah, great.
So if there aren't any other questions, I'll just make a really brief announcement, which is you all should join us again January 12th at 11 a.m. Eastern time for our next event, which will be with Janine Nantasenamat, who will be talking about using Shiny apps towards the development of interactive tools in bioinformatics. So we're very much looking forward to that talk. He's a popular YouTube influencer in the data science space and does a lot with Python and R. So I think he'll be a great presenter to hear from.